Okay. Once again, good morning, class. Welcome to today's lecture. Today, I would just want to. Okay. Today, I'm just going to solve one or two problems. That's why I requested for this edition of chemistry past papers. If you are writing any exam, you're here to make this material your companion. I can tell you for free, you are on your own. But let me tell you the materials you needed to pass exam. These materials are like a doctor's prescription. If you're writing any external exams like UTME of any university, nursing school colleges, universities, polytechnics, monotechnics, I don't have a guide like this. I don't think you are in a pathway to succeed, because this exam are not like your conventional JAMB or WAEC. The questions are highly technical. It requires that you have to think very fast. And materials like this have provided that avenue to study and study very well. You have the nursing edition. It is very fantastic. Fantastic in the sense that you have up to 4 items or 5 courses inside one package. Yeah, you see physics there, you see mathematics there, you see biology, you see chemistry, you see current affairs of different schools. That did not give you that opportunity to have enough examples or questions to tackle. But you see this one is only chemistry. Questions that you're going to see here are much more than that you see in the nursing. You need the two of them. You need the two combined. So if you have only nursing, you still need this. You still even need the small, the what do you call it? The catch up, to catch the two of them up. Education is not for the weak. You need to invest. That is investment you are making. I know things are not that smoothly normal, but you need to thrive. I'm just giving you an antidote to make it. This one, the nursing edition, and then that catch up. With these 3 items and coming to lectures, there is nothing on earth that will not. There is nothing on earth that will make you not to pass this exam, except your village people are very strong at it. But even on how your village people are difficult, are very proving difficult, with these items, you are going to what? Stampede them. But if you don't have these materials like your bulletproof, any arrow they will strike at you, they will get at you. And they can just attack a pull away. Just stumble. So again, I will encourage you. If you have one, there is no problem. But if you have more, if you have money, you can go for the 2 package. They are different. They are saying they are doing different things at the same time. The questions are not the same. Okay? But you know that all these your school of nursing, the questions are from JAMB. You will see some questions from here that they are asked. But this will give you more question tag than that of nursing. Because that of nursing, the whole subject are in one booklet. So you can have this, have that one, and then catch up with all of them with that material. The 3 of them work hand in hand. So if they work hand in hand, so if you are here to pick it up, please, I encourage you to do that as soon as what possible. Any school exam. It is not only restricted to UNTH. Okay, I will just do one or two. I just said 1 or 2, and then I'll go to a new topic as time is no longer on our side. In 2 weeks' time, this academy will start up a holiday program. So some people will be joining you. That means another class will be created. So we need to be up to speed to cover as much as we can cover before that program will start. So today, I would like to expose you in some certain areas, questions on Geluza's law. I think I'll just do 3 questions and I will leave it at that. And then we'll continue with another topic. Okay, let's see to this question. Or you take it down. You write down. There are some of them that we have done in the other nursing, so I'm trying not to repeat the questions again. All right. What volume of oxygen? What volume of oxygen? Are we there? I said what volume of oxygen will remain after reacting? Will remain after reacting? What volume of oxygen will remain after reacting HCl of hydrogen? HCl of hydrogen. HCl of hydrogen with 20 cm, HCm cube please, HCm cube of hydrogen with 20 cm cube of oxygen. What volume of oxygen will remain after reacting HCm cube of hydrogen with 20 cm cube of oxygen? While I copy on the board, those that are good to go can start solving. What volume of oxygen will remain after reacting HCm cube of hydrogen with 20 cm cube of oxygen? Option A, say it is 10 cm, B 12 cm, C 14 cm, D 16 cm. And the answer is what? Okay. Oh yeah, let's do it together. Let's do it together now. First of all, you have to form an equation for that reaction. What and what are reacting? Hydrogen, Abi? Hydrogen is reacting with who? Oxygen. And what are we going to produce here? H2 and what? O. Yeah? Hello? Okay. All right. Is the question balanced? What do we do now? What are we putting to? Is it here? Where? There. I think that was what we do, isn't it? Is the question balanced now? What do we do? I think it's balanced now. That's the first thing you do. Water and oxygen. Can't it come out? I don't understand which one is coming. Plus O2. I know now. You know that one of the theories of conservation of mass says that matter can neither be created nor destroyed, but it can transform from one form. So you cannot have O2 here again. It has been transformed, so it is no longer oxygen again. So if oxygen comes to this place, it means that the reaction were K-leg. There's a K-leg in it. So there must be a transformation of matter. Right there? So the oxygen will no longer be on the other side. So it will be totally transformed. But the fact will remain that the number of atoms of oxygen on this side must be equal to this side. So that's what will take care of it. So as it is now, there are three things that we need to do under each of these species. One is to state the volumes before the reaction commences. Before this hydrogen reacts with oxygen, its volume is at what? 8 cm. You come here and write what? 8 cm of what? Cube. Are you there? Before that, let me also tell you this thing that this is what? 2 volume, right? This is what? 1 volume. And this is what? 2 volumes. So, could check it there. Then, if that is now enough, next is now what is the volume of this man when he reacted with this man? Before it reacts, it was at what volume there? 8 cm what? Cube. And this is what volume here? 20 cm cube. And since they have not reacted, this is still yet to be formed. So as it is before reaction, this is at what? 0. Nothing. Dash. So now let's see how the reaction proceeds. The reaction going on is now like what do you call it? It's now like obeying Gelusa's law of combining volume, which says, if this one is 1 volume, it needs to be 2 volume. Oh, right there. If this one is 1 volume, this one needs also to be what? 1 volume. Compare the volumes and come up with what happens after the reaction. I mean, what happened during the reaction. So this is what happened before. I should have a space to be putting all these things. So this is what? Before. This is now during. Now, the reaction has not commenced. So commencement of the reaction is like obeying Gelusa's law of combining volume. Let's see how to obey it. So it like remove that's obeying that law as a side reaction. It's not part of our reaction. So but anything we're able to form at the course of that side reaction, we come and plug it as volume of what we recovered during the what? Reaction. Then after the reaction is like, what is remaining now is what? What is before and what is during. You minus, then get what happens what? After. So there are 3 things you're going to write. This volume is the one that you have already in the question. Next volume is the one you're going to obtain now by trick or by hook. Right there? The last one now is the one that is the outcome of these two. You get it. And that will be your answer. Then what you now do now, any volume, the question says, what volume of oxygen will remain? You don't check what will remain under this oxygen. Anything that remains here is going to be your answer. You check it in the option. So let us do this now. So over here, I will link this thing here to just show you what happened during the reaction. You know, during the reaction, you're not going to be seeing this thing with the naked eye. We believe that these things are going on. So look at how it will happen. So here we have 2H2 is to what? They must be the same volume. Are you there? So the other one is 1. So the other one also should be 1. So this one is what? 1O2 also needs what? 1 what? H2. Are you there? Try to pair. Pair this one, pair this one. Well, let's see what the volumes are. Now, of course, you should know this. That 2 volume is already tagged at what? 8 cm. If 1 volume of this is at 20,
That means 2 should be what? Doubled, which is what? 40. Just be putting it here. You are done with this side. Let's come this side. If one volume of this is at 22, so still remain what? 20. So if this one is at 8, this one that is now 1 is going to be what? 4 cm. So what I will now do, I will check the 2 species here. Which one appears to have the smallest or least volume? Which one have the least volume there? Is it hydrogen or is it oxygen? Do you know what you will do? What I will do now is that since this one is the least, and I check this one is 8 here, and this one is what? 4. Anywhere I see 2 in this equation, I'll put 8. Anywhere I see 1 in this equation, I put what? 4. So here, what am I going to put here is what? During is what? Here is what? 8C what? M. Are you with me? So if I see 1, what am I going to put there? If I see 1, what am I going to put there? 4. So here is what? 4 cm. I'm seeing 2 here. What am I putting here? What? 8 cm. So I will now to find what happened after the whole reaction. Because we say what remains. So what is remaining after the reaction? I will now do like this to find what happened after the reaction. So I'll put minus here. 8 minus 8 is what? 0. 20 minus 4 is what? 16. This is what? 8. What shall I say? What volume remains? So after the whole reaction, what is remaining is what? 6 cm. 16 cm, isn't it? Is it in the option there? Correct answer is what? D. Yes, your question. Are you here yesterday? Ask me useless question. Does it follow? Onye na see no follow Abia lesson yesterday, or that you are here but you are sleeping. Obuni bia lesson ị ga-emebu ijegola akwụkwọ. Go catch up, you catch you, you my name. What your name? I will recap with one more problem. Recapping will be one more problem. I want to ask a question. What if the question is in the other way around? Asigi, what is the volume of residual gases? Residual gases. Any volume that remains, add it. Any volume, this will remain. This will what? Remain. These are residual gases. Gases fall after the reaction. This is not a residual. So you now say 16 plus 8 to give me what? 2. That will be the answer. If that is the case. What of? Who can tell me the limiting reactant here? The limiting reactant is who? Hydrogen. Why? Because it is the one that is being used of. I think I used milk and Milo to explain this in the last time, Abi. The hydrogen here is like the milk. The oxygen here is like what? The Milo. Because at the end of the reaction, what remains is what? 0. Are you with me? No cocoa. Please, in the online, I hope you are following. Leave this one. Are you which? All right. I have another one that's hello. I have another one. I have another one. Let me write it on the board. For this one, they even give you equation. They say 2H2 plus O2. If you are still struggling to understand this problem, and I think this is going to be your last chance. That means that after this particular one, if you are still struggling to understand, that means I'm not the one that will solve that problem. You look for someone else that will help you to solve the problem. So you see this thing is the same thing with what we did there. So, but the question is not a twist. It's just coming like a twist. Does that say in the above? All right. All right. All right. And the answer is what? Remember the last time I told you this, that Galileo's law states that when gases react, that they do so in same what? Equal what? Volume. Where?
O2. 2 O2. The answer is what now? 400. And now you cannot solve it. Now listen. You cannot solve it. I said what? Listen. Okay, now let me put the equation again down. From the equation, I will write this. Watch this. 2 of this plus 1 of this produce 2 of this. Let's see the volumes of this before reaction. So let's say volume before reaction. What is the volume of 2H2 before the reaction? Is what? Okay, before this one, let's put this in perspective. First of all, mole volume for this is what? 2. This is what? 1. This is what? 2. Is that clear? From the equation. That's it. So let's see volume before reaction. Volume before. It means volume before this sparkle with this. You go to that question, you see it there. What is the volume of 2 of this is what? 1000 cm cube. What is the volume of 1 of O2? 300. There is no volume given to water yet. So here becomes what? Dash. So let's see volume during reaction. This is where the big questions is. Okay. Let us try to do the volume here. So that to all these students that will just leave the class without permission. I think this is going to be the last time. This girl that left now will not come back. She will not come back. Okay. Now you see. Now let's just look at this thing in 2 ways now. In the reaction, I will state what is in the equation. And then I also state something that is not in the equation, the other way around. As it is now, 2H2 reacted with what? With how many O? 1 Abi, but they must be equal volume. So instead of writing it the way it is in the question, I will give it what? 2 what? O2. They must be equal volume for them to what? React. Then since O2 is 1 in the original reaction, so it means that 1H2 again will also have to react with what? 1 what? O2. They put the volumes there immediately. So since this one is double now, and as it is now it's still double, and when it is double, the volume still remain what? 1000. Hey, where are you going? Come back. Come back. I'll go from there. Don't worry, go. Go now. You are distracting my class. I will deal with you. Please, sorry, help me close that door. Don't worry, don't close it for me. Let me close it myself. Okay. In the question, there is only one here, but only that Galatians say they must combine with equal volumes. So since we have one volume of this at 300, what is the volume? Where are you going? Leave the class. Fast now, fast. I don't want to push you. Come there, I'll push you. Even putting something, you can imagine. Where are you going? Where are you going? All right, please don't be distracted by all these unserious creatures. All right, listen. So how many volumes is here? I've got 300, Abi. Upon double, what do you have here?
600.
This one is not half of this one, Abi. I don't think it should be 1,000 again, but what?
500. It has reduced drastically.
This is what is happening at the molecular level. Just like your pastor will tell you in the realm of the spirit, this is what is happening. So in the realm of the molecule level, this is what is happening. Just be seen that way. So what has happened to this one is going to be halved to what? Half
300.
We'll check the two species. Which one appears to have the least volume? Is yours still on hydrogen? Look at it here. At 2 is 600. At 2 is 1,000. At 1 it is 500. At 1 is 300. So let us choose what? Oxygen. So what it means that anywhere I see 2, I'll put what? 6. If I see 1, I'll put 3. What am I putting here now is what? 600. This is what remains. This is what remain or what we have during the reaction. Well, anywhere we see 1, what are we using there? 300. So here is what? 300. So what we have here is what? 600. Aquia? Well, let's see what is remaining after reaction. Let's see here. Volume after reaction. Well, let's see. Out there. So 1,000 minus 600. Omega 4?
400.
300 minus 300. Omega 4? Omega 4?
0.
You bring this 600 down here. What did the question say we should find out? What's the question again? The question say in the above, what volume of hydrogen would be left? So what volume is left after the reaction is what? 400. Is in the option. The answer is what? B. That settles it. Yes. Now listen, let me tell you something now. See, let me tell you something. This question can also be asked this way. Now they can ask you in the reaction, just the one we just finished now. The excess reactant is what? Who can tell me the excess reactant? Hydrogen. Or they say, what is the volume of the excess reactant? What's the volume there? No, now the volume is what? 400. It's the same question, but they can twist it. What is the volume of the excess reactant? 400. The excess reactant is dash hydrogen. Are you with me? The remitting reactant is what? Oxygen. What is the volume of the limiting reactant there? 0. Are you with me? Then what if they ask you, what is the volume of the resulting gases? Any gas that remains, what do? You add them. What will be the answer now? 1,000. Where are you going? No, the 600 is the product. So it is not the reactants. So, but this is resulting. Everything that remains from the reactant and product, you do add all together. Kilo Shena. He's just coming. Are you just coming? Okay. Have your seats. Okay. Maybe I'll give you one for the road, and that is it. Go ahead with your question. Okay, why did they choose oxygen, Abi, and not hydrogen? Good question. I was expecting someone to ask that particular question. Well, now let me explain to you. Everything boils down to Geluza's law of combining volume. Now listen to me. You know, in this reaction, I can see that now. In this reaction, the one that was used to sparkle the reaction, the one that ignites the reaction, is which one that ignites the reaction? Oxygen. Are you there? Oxygen is like an initiator. Are there? A catalyst in that regard is not a catalyst, because if it's a catalyst, at the end of the reaction you see it in the products. So, but you didn't see it in the products. I say it's the initiator, and it appears that the initiator will always be considered in the reaction. Outside all the volume, he was the one that was able to get reduced. Are you with me now? In the course of the reaction. So, whenever thing you are doing now, if you want to know what happened during the reaction, it all relies on the species that ignites or starts the what? Reaction. If you eventually use volume of the one that is higher in the reaction, I think it will what? The reaction will no longer be feasible again. You can see where a reaction where you can see you use zone K higher. You may see the case where you see during the reaction, what we have after the reaction is minus, negative. That's what it will appear. If you try using the one that is higher in the reaction, you may end up putting this one. Which one now? You may end up putting 1,000 here, putting the other one here. At the end, the answer will be what? Negative. So your answer can never be negative in this case. That's why you also choose this list what? 1. To make sure that you don't have any what? Negativity in the what? Volume. That's all. Come on, guard the negative. Let it be what? 0. So that's why. So check definitely use on carry high. Assuming now never use in carry high. You pay 1,000, you put 1,000 here, and then what happened again? You put 500 here. What happened? 300 minus. That is volume of any substance can never be what? Negative. You can say it is used up and it has what? 0. So there's no negativity here. So that's why we decided to choose the one that is what? Least in the reaction. Just to maintain that the volume can never be what? Negative. That one is a very intelligent question there. I think it's very intelligent. I think some people may be asking, why am I using least volume? That is the reason. Any calculation you use the highest volume there, your answer will be negative. And you can never see a negative volume in the option. Have you ever seen a volume where they are asked to find volume and your answer in the options are minus 1000? That cannot what happen. Okay. That's by the way. Um. Okay. Okay, so we realize that we are almost exhausted some important of this question here. Okay, look at this one. This one, say, look at this expression and tell me what it is. Equal volume of all gases at same temperature and pressure contains same number of molecules. Equal volume of all gases at the same temperature and pressure contains same number of molecules. This is an expression of who? A. Avogadro's law. B. Charles. C. Graham's. D. Boyle's. No, Coco. The answer is what? What's the equal volume of what's this? Equal volume of gases at same temperature and pressure contains same number of molecules. What are the molecules? 6.02 times 10 power probably. That is what? Avogadro's constant. This full number of Avogadro. Take this last question. I'm not going to solve it. So everyone here, if you have really understand this particular topic, solve this one. Class work. Go. 200 centimeter cube of hydrogen. 200 centimeter cube of hydrogen. 200 centimeter cube of hydrogen combines with 50 cm cube of oxygen. Combines with 50 cm cube of oxygen. Combine with 50 cm cube of oxygen to form water at STP. To form water at STP. To form water at STP. Full stop. 200 cm cube of hydrogen combined with 50 cm cube of oxygen to form water at STP. Full stop. What is the volume of the residual gases? What is the volume of the residual gases? What is the volume of the residual gases? Option A, 100 centimeter cube. 100 centimeter cube. Option B, 50 centimeter cube. 50 centimeter cube. Option C, 200 centimeter cube. 200 centimeter cube. Option D, 250 centimeter cube. Okay. Your answer is what? 200. Alright, please make sure you solve this thing until you get it. After the lesson, give yourself the task. I must get it. I must not be the only person left. Others cannot be solving and be answering questions, and I'm the one that is not. Please make sure you get this. If I were you, I will not go without solving this thing, getting it. Okay, time may not permit us to wait for those that are struggling with this question. So I already have acid, base, and salts. Acid, base, and salts. See? You got 200. Thank God. Okay. All right, I have on the body here definition of acid. What is acid? What is acid? Yes? 200, that is it. So who cannot actually solve that problem? Let's raise up your hand. Let me see. You cannot solve that problem. Raise up your hand. You cannot solve. Raise up your hand. You better raise up your hand. So I'm thinking that everybody can do this one now. Only you. 2 of you. 3 of you. It's just that you are just coming, madam. So you cannot know how to solve it because they're just coming. All right. I have a new topic on about acid, base, and salts. I asked the question, what is acid? Yes? You want to tell us? You want to tell us? There are definitions. As I said, definitions. It's not one definition, it's not 2, it's not 3. There are so many definitions of acid. Okay, right. A substance or compound. Hey, you just coming. Acid, a substance or compound that produces hydroxonium ion. That produces hydroxonium ion. Hydroxonium ion, open bracket and write H3O plus like this. A substance or compound that produces hydroxonium ion in brackets is on the board. That produces hydroxonium ion in water. In water. Full stop. This is according to, who can tell me the scientists that define acid like this? This is according to who? This is according to Swente who? Swente who? Arrhenius. Are we there? So now, according to this man, general formula of acids, it says HA. Some of us don't know that acid has general formula. Name of what? Arrhenius. A-R-R-E-H-E-N-I-U-S. Arrhen. Can't you see hen is there? Arrhenius. So according to this man, the general formula of acid is HA. Is HA. Are you there? That HA can be HCl, so the A can start for radicals. Are you there? H A can be Cl, H can be what? NO3. Are you there? A can be what? A can be what? SO4, ATC. The man says that acids are substance that's in water. They become what? They change water to this structure. The H of the acid proton added to this 2H to give you what? 3 O, and the resulting compound becomes charged. What else do we have here? Plus what? A what? Minus. That is it. So any substance that when it dissolves in water can give you this with water, that compound is definitely an acid. So these 3 compounds you have here, HCl, can do that. If you react HCl with water, what are you going to have here? What are you going to have here, class? H3O plus what? Cl minus. So it's an acid. Are you with me? HNO3 plus water will also give you what? Class, what will it give you? H3O plus what? NO3 what? Minus. The same thing with this H2SO4. If it reacts with H2O, what do you think it will give us there? No, listen. In this case, these 2H needs 2 water molecules. Why other ones I need one water molecule? Because the H is just 1. So now that the H is 2, the H needs 2 water molecules. One will go for the other water, the one will go for the other water. So all together, what is going to come out here? 2H3O plus. So say here is 2 plus. What do you have here? Plus what? SO4, 2 minus. So any compound that in water will give you all of this, the compound is regarded as what? Acid. This is in accordance to Swente Arrhenius. Please take it down. Are we there? All right. There are 2 main types. That was paragraph where are you? There are 2 main types of acid. There are 2 main types of acid. There are 2 main types of acid. Namely, number 1 is what? Who can tell me? 1. What is this? Organic. Or what exactly is it called again? Natural what? Acid. Then 2 is what? Inorganic. Or what? Mineral what? Acid. If they say main means the major, the primary type. There are other types, but those ones are not primary types. There are other types like strong and weak. Are you there? There are other types like dilute and what? Conk. But the main type of acid is what? Natural and what? Inorganic. Well, let's take it one after the other. Organic acid. Organic acid. Organic acids are acids of plant and animal origin. Acids of plant and what? Animal origin. Plant and animal origin. They are acid of plant and what? Animal origin. Origin. No, what does it mean? It means that this acid originated from where? Plant and animal. Full stop. Go to the next line. The following are common organic. The following are common organic acid. and their sources. The following are common organic acid and their sources. Organic acid and their sources. Source. The source of citric acid is what? Lemon or what? Lime. Orange is not a source of citric acid. Anything like what? Citrus. Now citrus are fruits. Lemon fruits. It is called citrus. But the reason why it is called citric now is that there is an acid in the citrus. That acid, you can harness the acid if the citrus is unripe. Just like if you are licking an unripe orange. How does an unripe orange taste? Sour. And that's one of the characteristics of compounds that have sour taste are regarded as what? Acid. All right. Any compound that have a sour taste, 90 or 95% chance that that compound is what? Acid. Number 2. Yes, who else can tell us another class of acid? Amino acid. You are there. Amino. Amino what? Acid. Who can tell us the natural source where it is from? Proteins. You know all these things I'm writing on the board. Lemon is a plant, Abi. Same thing with lime. Protein is from where? You can see protein. We have 2 types of proteins. We have first class protein. We have second class protein. Do you know which one is first class? First class protein are from animals. Like egg. You know egg. Egg is a first class protein. Why is egg a first class protein? Because it's from where? From animal. Beans. Is it first class or second class? Why? Plants. Before we oxalate you, let's go to the common acids we know, I beg. Which acid again? Gastric. Lactic. I'm hearing gastric. Please, there's nothing like gastric acid. You can only see that acid in the stomach. No. That kind of acid that you don't, is an animal secretion. It is enzymatic in nature, so you don't consider it a pure acid. It's just like a cofactor. It is not a pure organic acid. So we have lactic acid is very correct. Lactic acid. What is the natural source of lactic acid? Milk. Alexa, we should give me up to 10 natural acid they are meaning. Yes? Ascorbic. Where is it from? Or here now you're talking about orange now. Orange fruits. Next one. What? More. Need more. Ethanoic acid corrects you. Ethanoic acid. Where is it from? Vinegar. Number 6. I think we should have 10. We should have up to 10. Okay, let me give you one. Tartaric acid. Where is it from? Okay, can get this one from where? Grape sugar. Number 7. Somebody say oxalic. Where do you see oxalic? Oxalic is from where? Oxalic acid is from where? Tomato fruit. Tomato. Number 8, we have malic acid. Where is malic acid from?
From where? Your apple fruit, you know. Number 9. Number 9, we have fatty acid. You know fatty acid? Fatty acid is from where? Fats and what? Oils. Number 10, we have palmitic. Is it here? No, let me add it here. Palmitic acid. Where is this from? Palm oil. So that is it. And there are more to this one we have on the board. But take notes. The most asked question on this is this one. Let me block the one that the most examiners will ask you. This one, this one, this one, and this one. How many? 1, 2, 3, 4. This is the most asked. You see question like this. Which of the following is the natural source of lactic acid? What will be your answer? Milk. Or the type of acid in milk is dash lactic acid. So these are the questions will come up. Yes. Yes. It is the same thing. The acetic acid is an old name for ethanoic acid. It's old IUPAC name. Vinegar. You know what is vinegar? Soured palm wine. Oxidized form of ethanol is vinegar. Rapid oxidation of ethanol gives you ethanoic acid. At a point, you see a palm wine that you take, it give you a sour taste. That means the acid in that soured palm wine is what? Ethanoic acid. So it is called what? The source is from where? From vinegar. So away from this, let's talk about this one, inorganic acid. Inorganic acid. So you don't expect this one to be from plant and animal origin. So where are they from? You don't expect this one to be from plant and animal. So they are not acid from plants. They are not acid from animals. So where are these acid? From where? From mineral element. We'll write it down. Right. These are acid. These are acid. I want to test my mic. Okay, it's working now. These are acid. These are acid that contains mineral elements that are found. Mineral elements that are found in the earth crusts. That are found in the what? Earth crusts. That are found in the earth crusts. Full stop. Are you there? Full stop. The following are examples of mineral or inorganic acid. Mineral or inorganic acid and their constituent elements. So write it this way. Here will be the inorganic acid formula. Constituents, elements. You see what I will do now? I will give you the names of the inorganic acids. You will be the one to write their formulas. You will be the one to write the elements that are involved. Maybe I will just do one as an example. You do the rest. See my first example, because I'll give you the names of the acid. And you'll be the one to write the formulas of the acid. Now let's go to the first one. First one will be trioxole. Choose a simple one. I'll give you complex ones.
trioxocarbonate 4 acid. Formula is what? H2CO3. You'll be the one in the next one to tell me the formula. Oh. Just the one, just like the one I did. It is not rocket science. You have been taught before. So what are the elements in this one? Hydrogen, carbon, and oxygen. Don't tell me the number of atoms you see there. Just see the elements you are seeing there. What are you seeing there? One is what? You see hydrogen. You see what? Carbon, and what? Oxygen. Then the second one here, the one that we're going to do, write the formula. Second one is trioxonitrates 5 acid. 3 dioxonitrates 3 acid. 4 tetraoxophosphates 5 acid. 5 tetraoxosulfates 6 acid. 7 6 trioxosulfates 4 acid. 7 trioxochlorates 5 acid. I think 7 is okay. You finish it up. All right. Finish. This is a test to know those that can write chemical formula. I'm going to go around to check what you're writing. If you dare use words by Kogon in Puduma. Ide Yaga Kogon. I got Kogon's button. Yes. So what's the formula of the second one? It is what? HNO 3. The third one is what? HNO2. Is that correct? Ewo. Is it not diazo here? If you calculate the oxidation number of nitrogen here, that should give you 3. Next one is what? H3PO4. Another one is what? H2SO4. This one, H2SO3. The last one, HClO3. So you can now complete the other side of it. Constituent element. That one is not difficult. Basicity of acid. Yes, who can tell us what is basicity? Any idea? Yes. What is basicity of an acid? Yes, who can tell us? Yes. All right. This is the number of replaceable hydrogen atom from 1 mole or 1 molecule of the acid. The acid must be 1 before you consider it. That is basicity. I'd like you to answer this question immediately. What is the basicity of the following acids? 1 trioxo nitrates 5 acid. 2 ethanoic acid. 3 trioxo carbonates 4 acid. 4 tetraoxo for ethane dioic acid
5 tetraoxo sulfates, 6 acid, 6 hydrochloric acid. Please answer the question here. 7 trioxo tetraoxo phosphates, 5 acid. You see, one of these acid must come out in any exams you'll be writing. Look at the ones that will come out often, the ones that are very confusing, that will come out. I will just put them in. This one will always come out because it's confusing. So many people are going to fail it. This one too will come out most often. Sometimes they want to ask this one for a reason. They'll ask this one too for a reason. This one will come out. So these are the ones that will come out. 3 of them. So that means if you don't know how to write the formulas of this compound, you don't know how many hydrogen that is to be replaced. So first of all, and sometimes see how funny these examiners. See how funny they are. See how funny they are. Do you know these people? They will not want to give you formulas of this acid, but when you reach to this one, they will give you the formula. So see CH what? 3COOH. So they will confuse them more. They say think that all the H here are part of the what? Replaceable hydrogen, Abi? And you like, and they will put option A4. You like, hey, it's not 3 plus 1, 4. Basicity is 4. You will not just fail it, but you fail it very well. What is the basicity of this particular acid? 1. Now look at how to know basicity. Now if I react this CH3, if I react this HCO3 ethanoic acid with a base, NaOH, look at what is going to happen. The only replaceable atom here is this hydrogen. This one will replace this one. It will not replace this one. It can't do that. Look at tell me why. The bond, you know, this one is like CH bond, Abi. The bond holding this one is non-polar. You know what I mean? It's non-polar bond. You know what I mean by non-polar bond? The electronegativity difference of C and H, they are too close. You see what I mean now? So if they are too close, the range is too close, so there won't be a partial charge. There's no partiality, there's no polarization here. So but if you come to this side, where you have C, O, C now, C, O and H enjoy a whole lot of what? High electronegativity difference. Or the very wide. So this one can become plus. That is why ethanoic acid is a weak acid. Because before it will dissociate to release this H plus out of this compound, it will take what? Time. So opposite, this one will not replace it. So how many H is replaceable here? These 3 are not replaceable. We can't replace them. The only one that is replaceable is what? Is this one. Why? This H and O are hydrogen bonds, so it is easily replaced. So if it is replaced, what do you have here? CH3COO NH. This is a salt. And you know, if you want to name salt, you name metal first. So despite the fact that the sodium is on the what? Right hand side. Don't say because it's on the right hand side, you name from the left. No. Metals must be named first. So what is the name of this one? Sodium ethanoate. Why OH entering it is because it is a product of what? Neutralization. Or a salt couple. Then the H that is replaced combined with the OH to form what? H2 what? O. So how many hydrogen is replaceable in this particular acid is what? 1. Therefore, this particular acid is what? Is what? Class C. Monobasic.
Make sure you're writing very well. What is the basicity of this acid? You first of all know the formula. What's the formula of triazole acid? HNO3. So in the course of reaction, is only this man is going to be replaced. So like ethanoic acid, this acid is what? Monobasic. As its basicity is what? 1. I've seen questions where they will ask you, all the following are monobasic acid except. What if it's that kind of question? All the following are monobasic acid except. Option A. This one is going to be option A. Option A. Option B. Option C. Option D. Tell me the answer. All the following are monobasic acid except dash. The answer is what? So the answer is what? Hello? The answer is what? D. Of course. Okay, now let me give you the formula of those ones. The formula of this one is what? HCl, right? The formula of this one is HCl. Formula of this one is what? HNO 3. Formula of this one. So you see, monobasic. What is the basicity of ethane dioic acid? It's dibasic. It's 2. Ethane dioic is saying C H2 C2O4. That is the formula of ethane dioic acid. So what is the basicity of this oxalic? That is oxalic acid. This is the oxalic acid. That was oxalic acid that you source from where? Where is the source of this oxalic acid? Tomato. This is tomato. Formula of tomato acid. That's it. Oxalic. Yes. Oxalic, or you call it what? Ethane dioic what? Acid. Basicity is what? 2. These are basic. So these are confusions they will come up with. Please get to know the acid that just blocked here. Ethanoic acid, ethane dioic acid. Please add this one up. Sometimes it will be confusing. Please, the formula is what? H2C2O4. It will be coming out. This one too, and this one. HCl will also will come out, but I think you know HCl. I shouldn't tag this one because it's too simple. Or there is nobody here that doesn't know that hydrochloric acid is what? HCl. Then each time there is a reaction between HCl and any other reactant, that the H that will be replaced is how many? 1. So as it is now, I can come here. In fact, this is even clear to this side now. If I now want to use this one as example, if you still have space, you can still put basis here. How many number of this is here? 2. This is their basic. How many here? 1, 1, 3, 2, 2 what? 1. It's tribasic now. Once it is more than 1, they become poly. We don't call it poly. We don't call it polybasic. You call it polypyretic acid. Polypyretic. I'm not busting any of your small brain. Polypyretic. Pyretic. Polypyretic.
Once the number of H to be replaced is more than 2, what do you call the acid? So this one that are 2 or more are polypyretic acid. Those that are only 1 are monopyretic what? Acid. But this is what we use in advanced chemistry. But in ordinary level chemistry, we call it basicity, monobasic, dibasic, and tribasic. So it is at this level you are not meant to go beyond 3 atoms of hydrogen per acid. Okay, now right. Paragraph. In terms of strength of the acid, in terms of strength, in terms of strength of the acid, in terms of strength of the acid, acid can be classified into 2 types. Acids can be classified into 2 types. Acid can be classified into 2 types. Namely, number 1. What's number 1? Strong acid. Number 2 is what? Weak acid. This is another type of acid, but that is in terms of the strength. Acid strength. In terms of strength of the acid. What is a strong acid? Strong acid. You can tell us? Strong acid. You will see questions like this. All the following are strong acid except. So you must know acids that are strong, acids that are what? Weak. But before that, what is a strong acid? Okay. We'll write it down this way. These are acids that dissociate completely. These are acids that dissociate completely. That dissociate completely in water. That dissociate completely in what? Water. That dissociate completely in what? Water. Full stop. That's it. Example. Who can tell me examples? Example, let's start from the small acid, small to high. Example, hydrochloric acid. Hydrochloric acid. HCl. Do you know why it's a strong acid? You just know by cramming. Comma. Other one. Tetraoxosulfates, that's correct. Tetraoxosulfates. Why I'm giving the formula and the name is for those that are not strong in chemistry. I'm supposed to be just giving you the formula. Tetraoxosulfates acid. What's that? H2SO4. Is a strong acid. Next. Hydrogen fluoride is a weak acid. I'll fade it. Trioxonitrate 5 acid. Trioxonitrate 5 acid. What's the formula of that one? HNO3. Has it finished? Hydrogen peroxide is not an acid. Hydrogen peroxide is not what? An acid. Hydrogen peroxide is H and O. O is not an acid radical. Yes, now. The empirical formula of hydrogen peroxide is HO. If you put 2 here, become peroxide. It is like water. It's with additional oxygen. So that is it. HCl, this is another acid like trioxochlorate 7 acid. Do you know the formula there? HCl O what? O what? 4. Sorry, not tetra. Let's go. It is okay. Please
Find a way to know these three. For how many acids here? 4. In fact, let me tell you the simple truths. The one that at your level is 3. I just added this one. The one that at your level that are known stronger acids are what? This one, and what? This one. Why strong? We'll check the mineral element in each of these acids. Which mineral element is in the first one? Chlorine. Which mineral element are in this one? The main mineral element in this one is what? Sulfur. Which one is this? Nitrogen. Which one is this? Chlorine. Do you know why they are strong? See why they are strong. All of these mineral elements that I just circled now, they are in their highest state of oxidation, except this one, because this one is not the highest state. The state of oxidation of this one here is what? -1. I don't need to tell you why it's -1. You should know why it's -1, isn't it? Which one? No again. No. Have you forgotten that the number of hydrogen with any other element combined is what? +1, isn't it? Have you not also know that also number of atoms of element that are all combined together in a compound is what? 0. If I know that this one is +1, so what there should be chlorine, so that the sum should be 0 there, -1. So all other ones apart from this first acid. Listen, please listen. Who can tell me the oxidation state of sulfur here? You don't even need to tell me. It's showing here. What is this one? 6. Which group does sulfur belong in the periodic table? Which group? 6. Have you seen that this acid is in the highest state? If I have something like H2SO3, is this acid a strong acid or a weak acid? You know why it's weak acid? Because sulfur, if you check sulfur here, sulfur is +4, not in the highest state. That is why this one is weak, this one is what? Strong. So if I want to give you maybe a multi-choice question, I will put this one in the option. All the following are strong acid except. You will see this one in the option. You will see this one in the option. This one in the option. This one in the option. 1, 2, 3 with this one 4. All are strong acid. Which one is in an exception there? This one. Why? The state is 4. Which state is this nitrogen? Which state is this nitrogen? Plus what? +5. If you have any other acid with HNO2 now, they say, is this a strong acid or a weak acid? Weak acid. Why? Nitrogen here is 3. It is not as high as what? HNO3. The same thing goes to this acid. What is the state of chlorine in this particular acid? State is what? +7. The last time I checked, chlorine is in which group? Group 7. The only one there that appears to be strong but is not in the highest state of oxidation is what? Hydrochloric what? Acid. That is it. So what it means that now in water, listen to me, in water, they all going to dissociate completely. Look at the complete dissociation. Let me use one as an example. HCl in water is going to completely dissociate to what? H plus what? Cl minus. If I use an arrow going only forward, it means that the dissociation is completely done. But if I have an acid like CH3COOH, the acid is very weak. Why is it weak acid? Because this acid is from all acid from plant or animal origins are weak acid. This acid is from which origin? Is it from animal? Is it from inorganic or organic? Organic. Where is it from? From plants. From where? Plant. Palm wine. Where is palm wine from? From plants. So all organic acid are weak acid. Why are they weak acid? They are weak acid. There is nobody here that is okay. There is nobody here that is okay. Let me tell you how they are not okay. O here is minus, all the O's here are -2. H here +1. Carbon here are in the negative direction. Minus. So what are they okay about? So it means that if they dissociate, they will do go front and what? Go back. If they go front, they give you what? H plus what? CH3COO minus. It means that if they give you this and this, if you are just sleeping, they will add and give you this again. So they dissociate and they what? Dissociate back. So it means that their dissociation is what? Is what? Partial. Because of that partial dissociation in water, the acids are what? Weak. And there is no acid there is no organic acid that you can at least say that the acid will dissociate very well in solution. They will dissociate, they will dissociate and maintain equilibrium. They dissociate at the point whereby you cannot say that this H plus is there, because as it is now, the reaction is reversible. What is reversible? It means that as the reactant is giving product is also giving what? Reactant. So there is no net change in the concentration of the reactant and what? Products. So all the acid that you didn't see here mentioned, or any acid in our here now, are considered as what? A weak what? Acid. They all considered as a weak acid. So you know what I tell people? I tell people, since you know that these four acids are strong acid, any other acid that you know that are not here, for example, this acid, and even this acid, H2CO3, this acid, together with ethanoic acid, are what? Weak acid. 4:4. I've mentioned 4 as strong. Which 4 am I going to mention as weak? Number 1, number 2, number 3, and what? Number 4. Weak acid. Are we taking the examples of weak acid now? Well, let's go to, strong acid. Let's go to weak acid. Somebody, weak acid. Weak acid. Weak acids are acids that dissociate partially. Into their ions in water. Dissociate partially into their ions in water. Example, trioxocarbonates. Carbonate what? 4 acid. Formula is H2CO3. Another one is what? Trioxosulfates 4 acid, which is what? H2SO3. Another one is what? Dioxonitrates 5 acid. 3 acid. 3 acid HNO2. Another one is what? Ethanoic acid. CH3COO what? Hey, let me use this one as an example. CH3COO. How to know they are weak? You will see this arrow like this. So when it is associated to give you what? H plus CH3COO minus. Their dissociation is not done with good faith. It dissociates and they return back to their reactants. Are we there? Acid can also be classified into what? Acid can also be classified, but these are not the main one. Classified into one, strong acid. Strong again. One, concentrated acid. Two, diluted acid. Let me use dilute. Concentrated and dilute acid. So that is it. Another way you can classify acid, conc, and what? Dilute. That one doesn't need explanation that much. Okay, let me explain to you what is conc acid. Now, conc acid is when an acid is already in water. Hello? Watch this. Let me use this as water. Let me use this as acid molecules. Are you there? So now, if in a container, if you have more molecules of acid, like if the molecules of acid, you see that these molecules are more, and then this dot, which I say is water, are few. If all of these things are mixed together with more molecules of acid in a container than water, the solution, the resulting mixture now is what? Concentrated. And this kind of acid is the one that you say, when we say acids are corrosive, actually the type of acid that is corrosive is what? Conc acid. If you have, this is conc acid. If you have, please explain, I'm not going to give you any note on this. Just say, this where this one here is what? Water. And this one here is what? Acid molecules. So if you have in the other way around, in the other container, where you have more molecules of water, if I have more molecules of water and maybe few molecules of acid, what do you call this mixture now together? Dilute acid. This acid may not cause any harm to you. So these are the kind of acid we use in the lab, maybe acid-based titration. You can use it in the lab, do acid-based titration. The acid can pour in your skin without doing any much effects on the skin. But once you are working with this one, you must be very, very careful. If you work with this one, you must wear lab coats. You wear hand glove. At least by the time it's first have contact with the hand glove or this thing, by the time it starts to react with that one, I think by that time your skins are what? Safe. The reason why you are asked to wear lab coat when you are going into the lab to perform experiments is because of this reason. So don't wear lab coats to show yourself. You only wear lab coats for safety measures. So when it says you're wearing lab coat there, no, it's not show yourself. All this we see in the school that you want to do practical in this particular lab. This is not same people. You see them wear lab coats on top of that. It's just because so these hazardous chemicals don't what? Get to their skin. Because some of them are what? Corrosive. If we are working with concentrated what? Solutions of those chemicals. Again, acid is not the only chemical that is corrosive. Bases are also corrosive. There are some salt that are also what? Corrosive. Except that the amount of water in those particular chemicals are more than the chemical itself. That is the only way we can say, hey, this is what? Diluted. But at O level, most of the acids we are working with or bases we are working with are what? Diluted up to what? 1,000 times. You know what I mean? 1,000 times. That means the amount of water in each diluted solution is 1,000 plus. Does anything we do in chemistry say per 1,000 cm? Is it not true? Per 1,000. That means this thing means that this thing is diluted up to what? 1,000. That means little small thing, you must put water up to 1,000. Small chemical, 1,000 water. Small chemical, 1,000 water. Just to be safe when you're working with it. After all, they say atom is the smallest particle of an element. Which what? Which does what? Which can what? I want you to define atom for me. smallest part of an element which can take part in a chemical reaction. No matter how small that acid is in that water, it must react. If you like, let it be 1 molecule versus 2,000 molecules of water. It will still react because it's there. The only thing the reaction is as fast as if the concentration were more. That's when they say state factors that affect the rate of chemical reaction. The first factor you must state is what? Concentration. The higher the concentration, the higher the rate of what? Reaction. If you want it to be fast, increase concentration. But if you want to be safe, reduce concentration. That's why sciences is not for careless ones. If you are careless, you cannot be a chemist. You cannot be a scientist. Some of you are very careless. Because you are being trained now in the future, to handle human beings, not chemicals. Because let's say you are working with sodium oxide, next time you are working with patients, human being, in the lab. So it's how you manage those chemicals when you are in secondary school, is how you are going to manage human being. That's why in secondary school, our own practical biology is with rats. You know rats now? Rats, rabbit, all these things that are mammals, but they are small mammals. When you enter into university to study medicine, nursing science, they are not going to bring rat again for you. They will bring something like what? Cadaver. You know what is cadaver? Dead bodies. Those things you're working with dead rats. You will be working with what? Dead human beings. Yes, practical. That's why you see some of them here. You see they are going for posting. UNTH. What are they going to do? They know that that's where dead bodies are. They will go there. They will get to the lab. Where anatomy lab is there, not here. Anatomy lab is in that UNTH, the main site. They go there, you see dead bodies. They will bring one for you to practicalize. They will show you the obotrato foramen. They will operate it. You put your hand, you'll be looking for it. Or if you go to their demonstration lab here, they have it as model. You know what is model? Model, they like use silicone, artificial silicone. Silicone can look like our skin. Silicone chips. They use it to construct a model of you, like this you now. They construct your model now. They put every heart, put everything, they will put it, but you know that cannot be as humans. So they prefer to use what? Humans than what? Those model. That one will give you what you want. Okay, that is for strong and what? Weak. There's no examples. This particular one can be strong if it has more molecules of this than water. It can be weak if it has more water than this. Mind you, anytime you are preparing a diluted acid, make sure that acid must be put into water. Are you there? What I say, if you want to prepare acid that is diluted, you put the acid into water, not water into what? Acid. You know why this is like that? To avoid stories that will touch the heart. Because acid reacts vigorously with what? Water. Are you with me? I say it again. Because acid reacts what? Vigorously with water. That is why in the lab, if you want to prepare dilute acid, you don't put water into the acid. You have to see. You have to have water. Look at how it is done. Water must be in the container. 1,000 molecules of water. Then if you're not adding the acid, you'll be adding the acid small. One molecule will enter, second molecule will enter. As they enter, the large molecule of water will now dilute the molecule of the acid. But if the acid is here, we are now putting the water. One molecule of water will enter, the whole thing will splash on your face. They will react. Is it time up? There are people here, their work here is to be checking time. That is only what they are good at. You will give question on the board, it is not there they are giving the question. It is for you. Okay, the next class, I think we are going to be looking at preparations of acid. What's more, I have the copies It has finished through, but I decided that this particular one is only people have called me to send this one, but they are not serious. So the serious ones here can pick it up before you regret it. The thing is still what? Asking I will change my mind. In fact, if I come next time, I'm going to solve 15 to 20 problems from this book. Those calculative aspects. I will solve it for you.